guys, BBI here. I want to stop and say thanks for tuning in and checking out whatever the video is about that's about ready to come up next. If you could take a minute and hit subscribe, I greatly appreciate it. And if you enjoy what you've seen here, make sure to hit the like button. We'd greatly appreciate your support. Anyhow, guys, all that aside, let's get on with the show. Yeah, it's been so long since I used this camera that I don't remember where all the buttons are at. Well, guys, we're going to start from the opposite end. This is where we normally end, and this is where we're going to start. Because we want to start with just the performance test, and then we'll work our way down to how the box actually works on the inside. This is camera number 1. Here's camera number 2. That is a 1,000 watt slug in 5x, so 5,000 watts peak. It's a 5,000 watt slug in average. 5 watt slug in reverse, back from the Bird 10,000 watt dummy load. It's a 50 watt slug on the input to show input power. 5 watt slug between the amplifier and the 2950. So let me grab this microphone here. We'll start here. This is what I'm going to put into it for drive. About 12 or 13 bird. That's what it looks like on a 5,000 watt scale. Now we're going to go over here and we're going to look at our spectrum analyzer real quick. That's 50 through 0 megahertz. Hello, 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 hello. Hello, hello, hello. Our pass-through tune. Hello, 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 hello. Okay, so now I want you to notice how quiet this is. There's a lot of work that went into making this as quiet as it is, because this got 2 power supplies in it that literally sound like jet engines when they're running. You literally sit in the room with this thing running now. Okay, so let's do this first. 5 watt slug going forward. So we're going to put 1.5 watts into this magical device, and let's see what we get out of it for power. Tickling the 4K mark pretty easily. So now let's see what we're doing for dead key here. Go back down to 1x. 1.5 watts gets its 200 out. .700 watt dead key on the max end. We'll keep the thing at about 250 watts and then let it go. So 250 watts. About 41, 4200. Back over here to the spectrum. Now, the reason I'm using camera number 1 is because it's much lighter. It's got a quick, faster focal, and it's got image stabilization. So now, let's switch over to camera number 2, and let's start opening this up, and let's start talking about how this works on the inside. We'll be back. What are we doing? Hey. Hi. What are you getting into, huh? Huh? What are you getting into? All right, be good. Dad's got to shoot a video. Now look, guys, I normally would not even bother to shoot a video of this. This represents a lot of work, a lot of culminated time inside of here. Okay, a lot of effort on a lot of people's levels. I got to give credit where credit's due. First off, let me say that this isn't the first pill to ever be built. Not by far. It's just not. Time has passed, and you know, I was the first one to kind of bring these out on Front Street and have it in a case, completed, blah, 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 blah. But there have been people that have crossed these finish lines way before me. Okay, Prime was pretty much the first one. There's quite a few people out there that have tried to make 4-pill units, and I've never seen a video of them actually completed in a cabinet ready to go out the door in this state. It's very specific. The specifics of the communication have to be very clear. I've seen one video of one person that has got a pallet that's got 2 transistors on it and another pallet with 2 transistors on it, but that's only one layer of splitting and combination of RF power. So it's technically a 4-pill, but the combiner circuit is very rudimentary. And that's where a lot of this gets complicated, is the splitting and the combining of these. The way the parts work, rudimentarily work, present a little bit of a challenge. Apparently not that big of a challenge for most real engineers, since we've all figured it out, and there's transmitter sites out there that are running, you know, 20 and 30 of these together, supposedly. You know what I mean? It's just in my little community of radio operators, I haven't seen anybody else be able to replicate this other than Prime, and he was the one to first cross this bridge. I built the 2-pill unit for myself, which I've had now running for 4 years, and I use it as a driver. And I decided to build this one for myself as a driver, but he built his as well, just a product demonstrator, and to prove the fact that he can build, and his cabinet's way better than mine, and his boards are way better than mine. They're all made in house. But the other reason I wanted to do this video is because the company that I've been working with asked me to shoot them an advertisement, and that's really what this is. I wanted to show you guys a pallet that is a single transistor pallet that allows you to have a lot of flexibility as far as frequency, reliability, and obviously what I just shown you on the spectrum analyzer, without, you know, the ugly loveliness of the 9-to-1s. The 9-to-1 pallets, guys, are inherently very dirty because of the frequency width that they're allowed to cover. But if you go with a bifilar, standard transformer based pallet, a lot cleaner naturally, and you don't have to have a low or a high pass filter involved for the most part, but I still recommend that you still run one. Okay, so let's open this up. As I mentioned in the first segment, there is a lot of work that went into making this section quiet. So let's zoom on in here for a minute. As you guys can clearly see, this is the RSP 3000 48. Okay, this produces 62 amps, so we have 125.8. That's 100%. Everything's 100% efficient. Power supply at 48 volts in this little guy. The fans that they put in this thing are so noisy, and they run at a low RPM. Okay, when you first turn the amp on. What I mean by that is, check this out. That high pitch is when you start to load the thing up. So imagine you having to listen to that while transmitting in the background. Everybody's like, man, I can hear his fans louder than I can hear him. This chamber that I created, I don't know if you guys remember back, but I did a video on the 2-pill 188xr that I have. And I was cramming so much air through that thing that, you know, the fans sounded like jet blowers. And I was getting tired of listening to that in the background. So I built this little kind of anechoic wrapped horn chamber where the fan blade surface met another flat surface, then a hard 90 degree and another hard 90 degree and then another hard 90 degree, and just absorbing the high frequencies. Well, that's what we did here with this chamber. The back end of this is open about that far. And the lid here provides the seal provides the seal here. Well, the air has to come out. I took these apart and I flipped them around. I also played around with removing the fans and trying to simulate the load of the fans in operation. Power supplies have got a code in them that senses this particular startup of this particular fan, and I spent about maybe 4 or 5 hours working on that and realized it wasn't something I was going to be able to quickly just work around. It was going to take something a little bit more amount of time to work, and I just went, no, I'm just going to go ahead and build myself another little wrapped anechoic chamber and see how it works. So we have this open space, then it's a wrapped horn design where there's about 1 inch worth of opening here. So we have our first 90-degree turn here. Imagine the wall, the lid right here. So our exhaust air pulls in across all of our components, our cooling air. Our exhaust air comes out the back, has to make a hard 90 degree, then has to make another hard 90 degree, then has to make another hard 90 degree. Now the entire inside of this chamber is filled with HushMat Extreme. Okay. The power supplies are mounted on 2 layers of HushMat Extreme. The front of the cabinet has got 2 layers of HushMat Extreme up to here. Okay. The bottom of the anechoic chamber is 2 layers of HushMat Extreme. The lid is a top and a bottom layer of HushMat Extreme. The first baffle is HushMat Extreme with little strips of HushMat Extreme in it. And what I mean by HushMat Extreme is that it's got the regular diamond or regular Dynamat coating, and then on top of that it's got a soft foam. So it slows down them upper frequencies. That and the other thing is it adds density and weight. Okay. After making all these hard 90-degree turns, we've killed probably 85–90% of this noise. Let me help put that in perspective. Once again, the entire inside of the lid is all covered with HushMat all the way around. HushMat, 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 okay? And then there's a 2-layer thick piece of it that's on this end of the cabinet. We got to put this together just right because that HushMat locks into that chamber. And now we're listening to this instead. There's a significant difference. Significant. See what I'm saying? A lot of time and thought went into that. A lot of time and thought went into that. Power supplies and controlling the power supplies. Now, let's go talk to my fellow friends in the amateur community. Gentlemen, hi. I know that you've all struggled with one particular thing when it comes to high-end switchers. I'm going to give you guys this little tidbit of knowledge, and I expect you to share it with my name attached. And don't try and pretend like you're Moses come down off the mountain with this knowledge and be like, oh no, I thought of that first back in the 50s and 60s. If you learn from this, great. Please share with my name attached. If you already knew about this, hey, great. Props on you. I wish you would share it with the rest of the community, because when I go out and I look at the amateur radio forums, it is page after page after page after page of, one, how do we get rid of the automotive high voltage noise light from our LEDs in our receive? And two, with our high-end switchers that run off above 12 volts, how do I get rid of the noise on 80 meters and 40 meters and 160 meters and so on? Try here. The way these power supplies work is down the side of this cabinet, this particular design. Down the side of this cabinet, you have your actual output bus bar. The transistors bolt directly to that bar. So the MOSFET that runs the switch gate that controls the internal circuitry of the power supply switch, there is zero isolation from it to the outside world. And it is a phenomenon that takes place exclusively on the positive distribution bus, okay? So I bought a bunch of these, and at $400 and some a piece, these RSP 3000s, I bought a bunch of these, and I figured this out probably 3-4 years ago, and I didn't realize anybody else in the radio community would have any use for this. I had no idea, otherwise I would have shared it a long time ago. I bought a bunch of these, and I went and I slapped them inside of a device, and I turned the radio on, and I got like 9-10 pounds of in my receive, and it was from the power supplies. The gate switching on and off and the MOSFETs all switch at about 4 megahertz, which is just outside the 80 meter band. So first I couldn't figure out where the noise was coming from, so I chased it around, and I found anything that coupled to ground on the cabinet increased the noise floor in my receive. I went, okay. I figured out the noise was coming from the switcher. So then with the spectrum analyzer, when I got one with decent sensitivity from Siglent, this is when I really started looking for it. Now I could sit there with my HF radio and just kind of spin through the band and be like, wow, look at how strong it is around 4 megahertz. That gave me a good idea. It gave me a really, really good idea where it was at. But I started playing around with different ways to choke it. And in the beginning, the first couple generations of these, I was putting chokes on the positive and the negative wires. Well, come to find out, it's not a ground issue. And what was making me falsely believe it was a ground issue was anything that I coupled to ground, like the capacitors back here in the back of the relay that you use to tune your pass-through capacitance, would dramatically, if I put them in line, because they couple to ground, you know, the AC can pass right through the capacitor. The noise would just significantly increase. So I thought it was something on the ground side. Now, come to find out, this is a problem that is solely existent on the positive side of the circuit. So as close to the switcher as you can make it, you have to create yourself some kind of choke. Now that I've explained the choke, how do we make the choke so it can carry up to 200 amps in a continuous duty and make it small enough to where it's not going to suck up a bunch of real estate? The first one of these chokes I made with a piece of ferrous rod, barric material, type 43, actually. It was actually a plate choke out of an SV220, but I took and I wrapped 8 gauge on it. And I played with it on the positive and I played with it on the negative. And I watched my signal 4 and my corresponding radio go up and down and, you know, count the number of turns in this, you guys. Okay. That is type 43 rod. I'm going to give that to the radio world. Very, very important. Without this, the rest of this doesn't mean shit. Because you can't hear with this device in line. You can't think with this device in line. And if you're out there trying to work some little tiny station that's hitting you at about 2 or 3 S units, you ain't going to hear them underneath the 9-10 S units worth of hash that these power supplies create. So I've seen a lot of builders here recently say publicly, oh, we're going to go to iron, back to iron. Okay, or we just build a choke. I built a choke, and it works beautifully. I have zero, and I mean zero noise in my receive, even on 80 meters. At 4.15 megahertz, I have 2 dBs of noise from these units switching and doing their job. Other than that, these are a beautiful power supply. The import tariff has really affected the cost of these. There's a time when you could buy these for $150, $200 a piece. This is a medical grade continuous duty power supply. It's Euro. The CE is a Euro certification. And it's also UL, which is the Underwrite Laboratories of the United States certified. This is a great piece of equipment. Good crowbar protection. Linkable units, external voltage control, all built into the unit. You don't have to even go into it. There's access ports right on the front. Neat unit. You can set these up so you have 1 master and 4 slaves, up to 4 slaves. I found that that's not necessarily true. You can have 1 master and up to 8 slaves. Power supply slaved off the primary one. Great power supplies. My microphone was starting to buzz at me, telling me that it was getting a low battery, and I didn't want to push it, so I just changed batteries. And I moved the camera a little bit closer, because now it's time for us to go talk about where the rubber meets the road. So we talked about the importance of this input, the power output filtration network. This is vital, by the way. Another little tip I'm going to give you is if you take yourself a 1/2 inch type 61 or type 67 ferrous rod and turn your coax around that 7 turns from the 2005 to current Dodge truck, you can eliminate all of the computer control noise that you guys are hearing in your receives and your HF equipment. I'll do another whole video on me chasing the Hopeless Diamond, which is a joke. The Hopeless Diamond, making a reference to the F-117 stealth fighter, of trying to figure out how to get rid of the high frequency switch noise in the new LED headlights in semi-trucks and new modern vehicles, which surprisingly enough costs a 4.5 cent part. I'll do another video on that to come. But for today's video, we're done talking about this choke. Please note there is no capacitance coupling anywhere on this to ground. That's absolutely something you want to avoid. Taking like a 103 or a 104, any kind of capacitor and coupling it to ground in this circuit, you do not want to do. I found toroidal chokes also not the most efficient at doing what we're doing. You have to increase the number of turn ratios, and there's engineers out there that are way smarter than me that can explain to you what that phenomenon is. I'm just telling you what my observational science has shown me, my observational measurements. And I wouldn't even go as far as calling it science. I would just say my observational measurements have shown me. So some other engineer out there that's smarter than me, or some click keyboard Nazi, is going to try and explain it so he can look like a god. All I'm going to tell you is this works. If you end up using it, please give me credit. That's all I ask. Okay, so moving on away from this, let's go down here where the rubber meets the road. Now, originally, I did shoot a huge intro for this where I just started out with the 4 MOSFETs sitting in this particular configuration, the LD MOSFETs, okay, that are sitting in this particular configuration on the table blank with the heat sinks, and me talking about what I was going to do and the theoretical purposes behind what I was going to do. And look, if you're going to attempt to build at this level of amplifier, you have passed the 2-pill section, okay. You've passed the 4 transistor device, you've passed the 8-pill transistor point in your building curve. Do not start trying to build here with RF amplification. There's a lot more to this than what you think. There's a ton of subtleness to this particular setup that a lot of eyes aren't going to catch. Some will, some won't. I want to give a big shout out to dnrradio.com. DNR is a company that I found through, believe it or not, eBay. In the beginning, we tried cutting our own pallets, and this would be considered a pallet. Anything that is not mounted to that's mounted to a heat sink with the device, the board, and you've got the means to put RF in and RF out, is considered a pallet. Okay. Now, the whole device completed is considered an amplifier. Okay. So there's 4 pallets. 1, 2, 3, 4. 4 pallets in this particular field of view. All right. These particular pallets, I contacted him, but I bought them initially off of eBay. I bought one of every single kind of pallet that there is out there, brought it here, put parts on it, evaluated it, and then proceeded to break them. Wanted to see where the weak points were at, and wanted to see what the vulnerabilities were. I've got a 9-to-1 pallet over here that looks like somebody took a blowtorch to it, because the kind of capacitors that they're using are not sufficient for what we want to do. But they do work. But they create a ton of 3rd, 4th, 5th, 6th order harmonics that are, we're not talking like 100 dB down or 90 dB down. We're talking like 5 dB down from principal. Okay, something that you have to be very concerned with. Hence the reason that we're very much wanting to promote, make sure to use your low pass and high pass filters, especially to the amateur community, you guys. If you're a home gamer and you want to try and build one of these in your garage or in your basement or in mom's sewing room, after you're done, make sure to use a low pass and high pass filter. Otherwise, your fellow brethren are going to get a little upset with you now. Okay. Each one of these pallets on their own, in theory, will produce about 1,500 watts of power. Well, that's way more than what I need. These are bifilar windings, and DNR was the first one that I found that has a publicly available palette. And what I mean by publicly available palette is that you can go on any common web search engine and get it, that actually would work and work well for the where we want to use it. So I'm going to put this out there. I've even looked at guys that have this particular type of output transformer, okay, but then they put coax in here, and they very sneakily cut the coax at the opening front of the transformer and then couple it to itself. That's another term for 9-to-1. That's still a 9-to-1. This is a straight piece of wire. Believe me when I say there's a lot of different reasons that I went with DNR. That, and he was totally willing and desired and wanted to come over here and come work with me. He's like, no, I'll totally work with you. I want to help, blah, 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 blah. So I had him tweak a couple little small things, and he sent me over the first test piece. I was happy with it, and then I totally let the subject drop because I was over this. I'm over these, by the way. These things are great, little amount of drive, produce great volumes of power. The problem is my market share, my guys, do not get that you can't take a single one of these and put a 100-watt radio into it. This device right here, this one device, this guy right there, takes about 3.5 to 4 watts, period. And then after that, you're going to blow the part up. The output side of these are completely indestructible. We've proven that with welding with them and shorting and keying them up with no antenna for a half an hour. And the output side doesn't care what you do to it, but the input side is incredibly sensitive. Hence the reason that we have all the attenuator in line. These are like 16 point something dBm knockdown attenuation, okay, on these pallets, times 4, and we're putting 11 in it. Each pallet's only getting about maybe a watt, if that. And with 1 watt of input basically going into each one of these pallets, we're getting roughly 4,000 peak out. So think about that for a minute. It's kind of cool. That, and I can pick this up underneath one arm and walk away with it and not get a hernia. So big shout out to DNR Radio. I suggest you go look at their products. The prices are fairly reasonable. There's a little bit of a wait time on it. Just saying. Good product. Now, this little power supply over here, you're probably wondering what this is all about. This is our primary contactor. Okay, this is what actually turns everything on and off. If you noticed in the intro of the video, this is a switchless design. I have the device that allows me to turn this on and off with an app. So I didn't want any switches on the front of this thing. But this power supply here is what runs our bias and all of our relays. It's just a little mean well. I think it's like maybe a 2 or 3 amp power supply. Runs on 220. And then it is also run through this contactor. So when we fire this, I love that big powerful ka-chunk. Makes me think I'm working with big iron. On. So yeah, that's the basic internal structure. This little relay that's sitting over here behind the coax, you guys can't see, this is our actual bias switch. That's what turns the pallets on and off. Over here on the DNR pallets, we have our fine and our coarse adjustment for our gate voltage. And then also we have, specifically this one here, is our temperature cutout, or thermocouple cutout. Which I believe that's just a little thyristor that when it gets too hot, it opens up and it shuts the gate voltage off and it kills the dang thing. I haven't gotten that far. I am going to mount these down and we'll put heat sink compound on them, don't worry. But I've been working on this on and off now for a couple weeks, and I'm finally to the point where I'm happy with it. I'm building this for me as a driver. I do believe that this is not the end of this conversation. What I mean by that is this is not the last time that we're going to have to come back and reiterate this. There's going to be guys out there that are going to take this knowledge that we provide them here today, and with other stuff that they come up with on their own, or with help from me or from other people or other guided help, or primarily on their own, and they're going to get more power out of these 4 devices with roughly the same amount of drive. That's great. I applaud them. I don't need any more drive than this. I wanted the same amount of drive that I'm roughly getting out of my 2-pill unit with 5 watts of input power, 6 watts of input power out of this 4-pill unit. I wanted to spread the heat out. Instead of getting 1,000% out of each device, I only wanted to get maybe half. There is, each one of the spreaders in here are a 1/4 inch thick piece of copper. The device is soldered directly to the copper. The screws that are holding the transistors down were in there just to keep the device from floating around or moving in the soldering process. I built this amp completely modular. The center strip can be removed. Each one of the side panels can be removed independently. And then the back panel that holds the combiner and the splitter network can also be removed independently and allows us full access underneath, plus having the heat sink and the spreader and all of its love are independently mounted down. Okay. So these plates are here just for us to have a good common ground surface for us to work on. And our ground leads come in here, 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 and here. And they're actually bolted to the board. A mechanical connection. I like soldered connections, but I wanted to be able to have modularity. The modular system allows me to be able to, if I have a failure, very quickly take something apart, interchange another part, replace it, put something else in its spot. I wanted flexibility, being that this is technically not a, if I was going to do this for a production, I would build this completely differently. This was just for me as a product demonstrator per se. Now, the hard part. Look guys, this is my output network over here. My input network is over here. I have this covered with tape for a reason. If you guys had any clue how many failures I've had over the years of working on this, look, this little stuff like this little ferrite shit like this, which most builders are very, very used to using, will not work. Okay? There are certain principles that these transistors rely upon to operate that don't like those. Okay? It does not work. And I'm telling you, it was a freaking chore to figure out how to make these combine together. So I'm going to first off stop and say thank you, Prime, for helping me learn how to properly manage putting these together and splitting the RF apart. You can buy the 2-port combiner and splitter network off of eBay, and it works relatively well. You can also buy a 4-port. The last time I seen there was a 4-port splitter and combiner network, but they don't show that in the amplifier running, number one. And number two, when I did purchase it and studied how it worked, they were only about 98, 97% efficient. There was a lot of heat loss. So shout out to Prime, big shout out to my buddy Donald, Shockwave. He's the one that taught me how to hyper monoband a particular device through a certain form of, I'll just say induction, with pure inductors. And that's what got me headed in this right direction. But big shout out to Prime, big thanks for the help in that department. So anyhow guys, this is the inside. This is what the inside of a 4-pill ldmos box looks like. It's real important that I show this as well. There are going to be people out there that are desperate to try and take from this. And so they're going to start creating things like, oh, it was all faked. Well, really? 5,000 peak, 5,000 average, 5 watt slug in reverse. Same exact setup, cabinet closed. Hello. Hello. Now let's just simply pan over and zoom in a little bit. Hello. Hello. 5,000 water. Water. This is an average. We'll turn on the Bird 43 peak kit. Enough said. Look guys, I wish I could give you a step-by-step instruction on how to do this. My big fear is that there'll be guys out there that'll attempt it. They're gonna spend an ass ton amount of money. Once again, here's the RF coming in from our Bird 43 and the RF coming out over to the line section, because there's gonna be guys that try and claim, oh no, he faked it, he had this sitting off screen, he did that, he did this. So it's pointless to me to fake anything. I'm afraid that if I go in and give a step-by-step instruction on how to build something like this, the home gamer is going to try it and he's going to end up being out quite a pile of money. There's probably $3,000 or $4,000 worth of parts in just this cabinet. Maybe closer to $4,500 worth of parts in this cabinet. And they're going to go home, they're going to try it. It's not going to work well for them, okay? And that's going to put a bitter taste in their mouth. And eventually that leads to people getting discouraged and then leaving the hobby. There's guys out there that are selling pallets like crazy. But then when it comes to showing people how to get it to the completed final stage, their instructions are very thin. They're not very clear. People spend a lot of money with you and then they end up having failures. And I know of about 5 or 6 guys that have literally just left the hobby because they're like, man, screw this. Can't get anybody to help me honestly. I know. I understand. That's what motivated me when I was a kid, to try and learn how all this stuff works so I could fix my own equipment. But gentlemen, I gotta go. I appreciate y'all tuning in for this short little, this is what it does, this is how it works, 4-pill unit video. Not trying to toot my own horn or anything, but I'm pretty proud of how this turned out. I cannot wait for other guys to get their videos out there running. Like, I'm going to get smoke checked here pretty quick. I know that when Prime ever decides to put his videos out on his products running, you guys are going to be like, whoa, way cooler than this little cobbled together internet bought parts. He completely in another different universe. So I know that I can't speak anything more about that. It's not my place to say about another man's business what he's going to do or what he's not going to do. So, or if he's even going to do anything. Don't know. It's not my business. I just think it's going to be cool, and I'm looking forward to it. So, on that note, big shout out to DNR Radio. As always, a big thanks to all of you guys for your support, tuning in, following along, helping out, support me with the likes up, the subscribes to the channel, the thumbs up on Facebook, helps keep me motivated. I got a big pile of work over here, guys, and I've been building this on my spare time on the weekends, and it's finally done. So I'm really excited to get this out of the way. And if you hear me on 6 or some other channel, I might or might not be talking on this as my driver. We'll see. I'm not going to say either way. Big shout out to Siglent, Excess Power, Bird, Coaxial Dynamics. Big shout out to Siglent. And another big shout out to Dispace. They're the guys that make my network analyzer. I use that KC901. It's so much more superior to the MFJ and the 33 zooms and all the stuff that you guys are using. It's actually got a signal generator in there, and it's got a load emulation circuit and a whole bunch of other stuff that I used that helped me measure the operating characteristics of each one of these pallets, and it helped me emulate the output operational load of each one of the pallets combined. That's what allowed me to be able to figure out the proper tuning for the output and input network of this particular device. So, and there's a guy named Charlie that's out there that I give big props up to too, but I'm going to leave it right there on the table. Guys, I gotta go. I've had a lot of help from a lot of different people to figure this out. I just want to make that really clear. And without our fellow builders helping each other out, none of us get to thrive or move forward. Thanks, guys. We'll see ya. Bye.